Awesome. All right, well, thank you for joining us today. We've been having some conversations about trucking and autonomy. Try to ask, mostly, I think, kosher questions and maybe some things a little bit sensitive, but I think overall a good conversation. So, first of all, I want to thank you both for joining us here. Marco, obviously, from Mercedes-Benz and Raid from Wideye by AGC. Perhaps we can first start by doing a very quick intro from each of you about yourselves and what you do at your respective companies, and then we can jump in.
Yeah, okay. First of all, thank you very much for having us, or me here today. It's my first Aeva day, and it's quite an honor here to discuss the Fireside chat with you. My name is Marco Zeuner. I'm the head of ADAS hardware architecture at Mercedes-Benz. And I'm also responsible for all the ADAS hardware components that are necessary to build up an ADAS system. It is including all ECUs, also the central ECU, but also all the sensors. And this starts at LiDAR. This goes from radar, camera, ultrasonic, and so on. So everything, all the ingredients that you need from the hardware side to build an ADAS system.
Thank you. Right?
All right, so myself, I'm Raed El-Makour. I'm Chief Product and Marketing Officer at Wideye by AGC, responsible for product strategy and roadmap and also marketing. So AGC is a global glass supplier focusing on architectural glass, automotive glass, and glass for electronics. And Wideye is a business unit within AGC taking care about sensor integration.
Makes sense, perfect. So why don't we jump in? So, I'm going to ask the obvious question on everybody's mind first. That's been going for a number of years, and I think a lot of folks talk about integration of sensing, including LiDAR in automotive. Maybe one or two don't. Can you talk a little bit about there's this big debate about LiDAR and how critical really is it for ADAS and automated driving? Do you really need it? Obviously, from a Mercedes-Benz point of view, and from your point of view, we'd also like to understand what you were seeing in the market. So perhaps we can start from there is, in the viewpoint of the need for LiDAR for automated driving, how do you see that from your perspective for the passenger car OEM space?
For passenger car, as Mercedes-Benz, safety is one of our key pillars of the brand core values. And we already had some experience there in implementing and developing systems, and we brought one of these systems to the market 3 years ago. It was the level 3 drive pilot. And when we are designing such a system, we think that redundancy is key. Redundancy in the system. And when it comes to sensors, we see that the use of a LiDAR is particularly indispensable for us, because besides, on the one hand, the traditional radar and the traditional camera, we see these three sensor modalities complementary, especially in their physical measurement principles. I give you an example. For example, when you're driving on a highway with 130 kph in a level 3 system, and suddenly your front cameras are dazzled by the low sun, you have the LiDAR on board and you have the radar on board, and these both sensor mentalities can take over, or they can take the load from the camera, and that's the reason why we think that redundancy is key here, and it is key that we definitely need a LiDAR for that situations. We can compensate the situation-dependent deficits of one sensor modality by the characteristics of another. And furthermore, maybe I have to add, all level 3 ADAS system as Mercedes-Benz use LiDAR as a standard technology. because we have to fulfill high safety standards, we have to fulfill SOTIF standards, we have to fulfill FUSA standards, and this is only possible if you have these sensor modalities on board, including LiDAR.
Very helpful, and I think very clear, so I appreciate that. Ray, from your perspective, maybe talk a little bit about that. Obviously, you're seeing it from a different angle, but what do you see in the market about LiDAR?
Yeah, so we are seeing the same trend we have seen before for camera and radar. So we've seen that camera and radars ramped up in volumes around 2010, 2012. And we are seeing the same trend now. So most of the RFQs we are receiving from OEMs, we can see that most of them decided on adopting LiDAR. Maybe one or two are hesitating, also not omitting the Chinese OEM as well. So we are seeing this, let's say, trend settling that LiDAR is necessary to achieve redundancy, as Marco mentioned.
Makes sense. All right, so hopefully we answered that question, at least amongst this audience, around LiDAR. Now let's talk a little about, obviously, there is different camps in technology. We are obviously biased. We are FMCW, a different camp than time of flight. But how do you view that, Marco, from your side of Mercedes-Benz, about FMCW and what that may be able to enable for you at Mercedes-Benz?
Yeah, we are observing FMCW for quite a long time, and we see that this indeed is a quite interesting technology because it provides additional information. For example, the velocity of a detected object. And this is really important for us, especially also in comparison to conventional LiDARs like time-of-flight LiDARs or something like that. And this, we can have advantages out of that for maybe specific use cases, like high-speed driving on a highway, where we suddenly have a lost cargo scenario. Detecting that lost cargo. But not only for highway use cases, but also for level 3 urban use cases, where you have various and fast-moving options in front of you. Here, these additional helps, and we are currently evaluating if this FMCW technology can provide us additional safety attitudes or application use cases for our customers.
Makes sense. And maybe continuing on, there is a discussion also after LiDAR versus no, yes or no, around the integration and where that needs to happen. For different use cases, as we go towards further and further advanced automation features, for highway application, you talk about for highway autonomy, for the lost cargo, and which just for the audience, that means having an object that falls on the road that is maybe small or hard to see. As also Jessica shared that earlier, there are these use cases where with our technology we can have a significant resolution and pick up that static object from a small distance. So, but moving from those functionalities, there's also questions around where to integrate these sensors. There is a huge kind of trade space of what you can trade off in terms of performance, experience from the user, design, and others. Can you, maybe each of you talk a little bit about that? Maybe Ray, we can start with you since you have a perspective from the windshield side.
Yeah, so we've seen that LiDAR started, or OEM started integrating LiDAR in bumper since 2018, so we can name Mercedes, Audi, BMW, Lexus, Stellantis, and so on. But we are also seeing that this integration comes with a lot of challenges, which is good for us, otherwise we would not be here. So on a car, you have today a lot of sensors already. So you have, in each car we buy today, you have around 7 to 12 cameras, depending on the OEM. You have 1 to 5 radars, depending on the OEM. And now we want to integrate a third sensor that will ensure redundancy, improve safety, and enable OEM to reach higher autonomy level. So the first question to be asked is, how do I integrate the sensor while preserving performance, ensuring lifetime durability, and preserving vehicle design? And for this, you have 3 schemes of integration. bumper, roof, or windshield. And if we go into pros and cons of each this integration, so for bumper, the LiDAR is placed on a low position, so the LiDAR only sees what's in front of the car. You have a dead zone on the side of the car. Since it's a low position, it's also exposed to dirt. Mm-hmm. Hence, you would need a high efficient cleaning system, which means that you will need an additional cost on your bill of material. It's a low position also, so it's exposed to damage by stone chip impact, even if the glass that we developed is developed to withstand those stone chip impact. But basically, if you are parking your car and you hit the car in front of you, you could also have a damage of your sensor. And this makes it mandatory, or the OEM are seeking today to move from this position towards a better position to improve performance, but also design. And you have two candidates. The first one is roof, the second one is windshield. Roof today is seen as the best integration position. It's a high position, so your LiDAR is one meter higher, 1 meter backward. And basically, you have a better peripheral view. You can see the cars on your right, see the cars crossing on your left, and you can also improve early detection of crossing scenario, for example, a child or a pedestrian jumping in front of the car. You have a glass in front of the LiDAR, and this glass is tilted by 10 to 15 degrees. It is designed to have minimum impact on performance. So from a performance point of view, roof is the best integration today. But it's also challenged because you will have a bump on the roof, so you are pushed to change the design of the vehicle. And you have also effect on aerodynamics because you are adding a secondary skin that will increase the drag coefficient. But this glass could be also shaped in a way, and this is what we are doing with multiple OEMs. The glass could be shaped in a way to lower this drag coefficient. Last but not least, you have the windshield integration, and this is considered today as the grail of LiDAR integration. You would integrate a LiDAR behind windshield without impacting any form or any style of the vehicle, so the vehicle will look the same. You have zero impact on aerodynamics. You have shared resources with camera. You have cleaning that is already in place. But you also have a compromise in performance because the glass, even if it's improved for high transmission, the tilt angle of the windshield will give you some losses. And this is where we are working with OEMs, including MB and also Aeva, to try to find a way to overcome this. So as a conclusion, we can clearly see that mostly all of the OEM are dropping bumper integration, and now the discussion is between roof and windshield. The good thing is that at Wideye, we have the privilege to develop both products. Of course, we and Aeva, we can accompany the customer in their decision, but at the end, it's an OEM decision.
It's very helpful. So, you touched on, I think, a good point, ended up at windshield integration. Obviously, we're working together for some time on getting this vehicle integration concept done as well. We have a vehicle here with a fully functional LiDAR integrated behind the windshield. Maybe Marco, you can touch on this topic from a safety and autonomous functionality perspective. How do you see the integration location of LiDAR sensor in the vehicle impact the functions that need to be coming on as you see the roadmap?
Mm-hmm. So for our first generation level 3 system from 2022, we decided to put the LiDAR in the grill, in the radiator grill. And of course, we made experience that Red already described, like stone chip, like dirt. We have to clean the LiDAR and so on and so on. For next generations and for next systems and applications, we are thinking about alternative locations for the LiDAR. There is the position on the roof that you already mentioned, but also the position behind the windscreen. Both locations have various advantages, but also disadvantages in terms of integration. And we are currently evaluating these things together with you. But currently we have not yet decided what is the optimal position for us. But we know that we want to place the LiDAR higher, because when we are looking in the future and have some, let's say, some roadmaps of level 3 and automated driving for the future in terms of level 3 or level 3 urban, we see that we have to position the LiDAR higher than in the grill. Yeah.
Very helpful. I think we covered a lot of topics around, LiDAR, need of it, integration concepts, how that fits inside vehicles. Perhaps we can end a little bit about kind of your views on kind of where the sensing market and enabling next levels of automation is happening. So, obviously, as you said, Mercedes-Benz is one of the first OEMs now that has a level 3 functionality in the US, including LiDAR. How do you see that kind of generational technology? We talked a little bit about, some of the advantages that you could see with FMCW, enabling that for small object detections, for highway, perhaps urban with fast-moving objects in and out of the scene. How do you see to the extent that you can talk about the roadmap of the functionalities that need to happen in the market from an OEM's perspective in terms of autonomous driving? So first the highway, is urban right after that? Is there something in the middle, or how do you think about that?
Mm-hmm. So we started with the highway application, but currently we see a strong push for level 3 applications, especially from the Chinese market. And we see on the roadmap that this will also be extended from highway to urban scenarios, and also in the direction of level 4 driving, but also parking. And of course, we are following the trend because we want to be competitive in all markets worldwide. And therefore, I see this push can be a benefit for the whole ADAS community worldwide. And of course, we are a global acting company, and we will bring that new systems and that new applications towards level 3 and level 3 urban, definitely worldwide to the market, not only for the Asian market.
Makes sense. Thank you. Ray, your perspective on functions?
So yeah, we are clearly seeing OEMs focusing on highway, but also urban scenarios, how to improve safety and in urban scenarios. We are seeing two schools here. So global OEMs started by highway pilot. China OEMs are more into urban scenarios, and now they started by improving level 2 by using LiDAR and then going to level 3. Global OEMs are more enabling a higher autonomy level, which is a level 3, and then checking how would I deploy my LiDAR in a mass scale towards my mid and low end segment for urban scenarios. Awesome.
Well, I want to thank you for joining us here today. Really appreciate your perspective. I just want to add that, from our perspective, what this all means for us is, obviously, as you highlighted, from a Mercedes-Benz point of view, there is, you see LiDAR as standard technology. We have been working on bringing the technology to mass production, starting with trucking space, now transition to passenger. And I think the economies of scale that we see from the innovations and investments we have made over the past number of years are starting to pan out. And as we deploy that first in automated trucking and then passenger, as well as active safety for commercial vehicles, because of the fact that we can use one perception platform, it's manufactured on the same line across these products, as well as the other markets that we have talked about. We'll touch on more later today as well. We're really excited about the opportunities ahead we have together with you, and we're looking forward to bringing this technology to mass production. So thank you for joining us, and with that, we're going to move on to the next segment of this.
Thank you.
Thank you.